Hi, good morning. Today we are going to discuss about bubble sort technique. Before that, we should know what is sorting. Rearranging the elements of a list either in ascending order or in descending order is called sorting. Sorting can be done in so many ways. Some of the sorting techniques are bubble sort, insertion sort, selection sort, quick sort, merge sort, heap sort, and radix sort. These names are assigned to the techniques based on the method of rearranging elements either in ascending order or in descending order. In this topic, we are going to discuss about bubble sort technique, how to rearrange the elements in ascending order, why the technique is named as bubble sort, and what is the time complexity of bubble sort technique. Bubble sort technique Bubble sort technique is a well-known algorithm to rearrange the elements of an array either in ascending order or in descending order. Bubble sort technique is easy to understand. Probably this is the least efficient algorithm. Let me explain this technique using an example. Let us consider the following array which is having 5 elements. Assume that we are going to sort these elements in ascending order. The elements in the array are 57, 25, 48, 37, 12. Compare the successive elements, that is, first element is compared with second element. Second element is compared with third element. Third element is compared with fourth element. Fourth element is compared with fifth element. If they are not in proper order, they will get interchanged. See here, first element is compared with second element. Are they in ascending order? No. So, interchange them. 25, 57. Now, second element and third element are compared. Are they in ascending order? No. So, again, interchange them. 48, 57. Now, third element is compared with fourth element. Are they in ascending order? No. So, 57 and 37 are again interchanged. Now, fourth element and fifth element are compared. Are they in ascending order? No. So, again interchange them. 12, 57. So, the elements are rearranged. We have compared from first element to last element. We have rearranged the elements, and if you observe that 57 is the largest element and it is moved to its final position. See this, 57 is the largest element in the array out of these 5 elements and it is moved to its final position, and remaining elements are also rearranged, but 57 is the largest element and it is fixed in its final position. What about the remaining elements? They are not in sorted order. See, only 57 is fixed in its proper position. What about the remaining 4 elements? 25, here 48, 37, 12. The array contains now 25, 48, 37, 12, 57. 57 is the largest element and it is fixed in its proper position. Now ignore this 57 and repeat the same procedure on the remaining 4 elements. Now again compare the same. First element is compared with second element. Are they in ascending order? Yes. So if they are in ascending order, we are not going to interchange them. Then second element is compared with third element. Are they in ascending order? No, they are not in ascending order. So interchange them. 37, 48. Now third element and fourth element are compared. Are they in ascending order? 48 and 12. They are not in ascending order. So 12, 48. So these 4 elements, 48 is the largest element and it is moved to its final position. So 48 is fixed in its final position. What about the remaining 3 elements? First element is 25, second element is 37, third element is 12. So 2 elements are already fixed. What about the remaining 3 elements? Not in sorted order. Now repeat the same procedure on these 3 elements. 25 and 37 are compared. Are they in ascending order? Yes, they are in ascending order. So no need to interchange. So 37 and 12 are compared. Second element and third element. Are they in ascending order? No. So interchange them. 12, 37. In these three elements, 37 is the largest element and it is fixed in its final position. So 37 is fixed in its final position. What about the remaining two elements? 25, 12, 25, 12. So now repeat the same procedure on these two elements also. 25, 12. 25, 12. Are they in ascending order? No. So interchange them. 12, 25. So 25 is the largest element and it is moved to its final position. Now in unsorted locations there is only one element at 12. An array or a list consisting of only one element, it is deemed as a sorted order. So finally, look at the final array. The elements are rearranged such that they are 12, 25, 37, 48, 57. Yes, sorted order, ascending order. It is a sorted array. See, to sort these five elements, we have moved several times from left to right. So in first pass, we have moved from left to right. In second pass also, left to right. Third pass, left to right. Fourth pass, left to right. So in a bubble sort, the elements are compared from left to right. Left to right. In every pass, one element is fixed in its final position. What is that one element? That one element will be the largest element. In first pass, 57 is the largest element and it is raised to its final position just like a bubble. In second pass, 48 is the largest element and it is raised to its final position just like a bubble. In third pass, 37 is the largest element and it is moved to its final position just like a bubble. And in fourth pass, 25 is the largest element and it is fixed in its final position. So in every pass, largest element will be moving to its final position just like a bubble. So this particular technique is said to be a bubble sort technique. Now let us consider the number of comparisons in every pass. In first pass, we have compared 5 elements and by comparing these 5 elements, we had 4 comparisons. First element is compared with second element is compared with third element is compared with fourth element is compared with fifth element. So, you may have 4 comparisons. In second pass, the list is having only 4 elements, so you may have 3 comparisons. In third pass, the list is 3 elements, so you may have 2 comparisons. In fourth pass, the list contains only 2 elements, you may have only 1 comparison. The total number of comparisons will be 1 plus 2 plus 3 plus 4. In an array consisting of only 5 elements, we have a total number of comparisons as 1 plus 2 plus 3 plus 4. If an array consisting of n number of elements, we may have comparisons like we may have the total number of passes will be n minus 1 and the total number of comparisons will be 1 plus 2 plus 3 plus etc etc n minus 1. There will be n minus 1 passes. Total number of comparisons will be 1 plus 2 plus 3 plus 4 plus n minus 1, which is equivalent to n into n minus 1 by 2 through induction, which is n square minus n by 2. This equation is equivalent to the total number of comparisons. The time complexity of any algorithm is directly depending on the total number of executable instructions. Here we can say the total number of comparisons. So the efficiency of algorithm depends on total number of comparisons. So in terms of big O notation, we consider this as big O of n square or order of n square. The time complexity is order of n square. The time complexity of bubble sort is order of n square, which is equivalent to directly proportional to the total number of comparisons. If there are n number of elements, the time complexity will be order of n square. Let me explain bubble sort technique using SC function. Void bubble sort a comma n. Bubble sort is the name of the function. A and n are formal parameters. A is array, n is number of elements in the array. An array consisting of n number of elements. We are going to sort an array consisting of n elements. An array consisting of n elements needs n minus 1 passes. So we need to sort n number of elements. To sort n number of elements, we have performed n minus 1 passes as per our previous discussion. So we need to perform something n minus 1 times. So there is a first statement for I assigned to 0, I less than n minus 1, I plus plus. We are performing some operation n minus 1 times. This is the operation we are going to repeat n minus 1 times. The operation is said to be a pass. We are performing some operation n minus 1 times. It needs n minus 1 passes to perform the bubble sort process. So in every pass what we performed, the elements are compared from left to right. First element is compared with second element. Second element is compared with third element. First element is compared with second element. Second element is compared with third element. Third element is compared with fourth element, etc. etc. If they are not in proper order, they are interchanged. See here, there is some procedure which performs interchanging. Say temp aj, aj is aj plus 1, aj plus 1 is temp. If the elements are not in proper order, the elements are interchanged. Aj greater than aj plus 1, perform interchange. If j is 0, for example, j is 0, j plus 1 is 1, 0 plus 1. So a0 greater than a1, a0 and a1 will get interchanged. If j is 1 and j plus 1 will be 2. If a1 is greater than a2, they will be interchanged. So aj and aj plus 1 will get interchanged using the three instructions. So this process is going to be repeated using again with some number of comparisons. In every pass, there are again some number of comparisons. In a particular pass, if there are n number of elements, we may have n minus 1 number of comparisons. See here, j is 0, j less than n minus 1 minus I, j plus plus. So this process again going to be repeated some number of times. J is compared with j plus 1th element, that is first element is compared with second element. If they are not in proper order, they will get interchanged. Second element is compared with third element. If they are not in proper order, they will get interchanged. Third element is compared with fourth element. If they are not in proper order, they will get interchanged like this. So there may be n minus 1 passes. In every pass again, there are some number of comparisons. Every comparison checks whether it is in proper order or not. If they are not in proper order, they will get interchanged. So there are n minus 1 passes. In every pass, there may be some number of comparisons. If the comparison is not in proper fashion, the elements are getting interchanged. So we are using two first statements, first statement and another first statement. Here there are n minus 1 passes. In here again, if there are n number of elements, there may be n minus 1 number of comparisons. Again there will be n minus 1 into n minus 1. So the time complexity will be order of n square. There are n minus 1 passes. In every pass, assume that there are n number of elements, there may be n minus 1 number of comparisons. In a particular pass, if there are n number of elements, there may be n minus 1 comparisons.